Okay, I think it's on live. Hello, hello, hello. Okay. Okay, so it's around 11 p.m. in Japan time. I'd like to start the live tutorial for this week. So, so this is Junichiro Horikawa, and this is the weekly tutorial live stream for Houdini, which is called as Houdini Algorithmic Live series, and this is the 93rd episode. And the topic for today is to do the so-called conformal mapping in Houdini using Vellum as a tool. If you don't know what conformal map is, conformal mapping is a mathematical term. It's a function that locally preserves angles and map one geometry to another geometrical dimensions. In my case, I am going to create a conformal mapping from 3D to 2D, meaning I'm going to flatten the geometry, three-dimensional geometry onto 2D space by trying to preserve the angle and local spaces, meaning you see that the angle on the local spaces is 90 degrees in this case, in this grid, and when you have map it onto another dimensions, and locally you are preserving the angle as much as possible, but the length of the mapped geometry is going to be changed, distorted. We don't care about the lengths, but we only going to consider the angle preservations, and that is the conformal mapping. And there are several utilities, there are several usages for this kind of mapping, especially when it comes to a geometrical engineering or optimizations. A lot of geometrical optimization or analysis are too complex to do on a three-dimensional geometry directly, so a lot of cases you first map the three-dimensional geometry onto a flat plane, so that it's gonna be much easier to calculate the the features, then bring it back onto the 3D after you have calculated the features on 2D, then use it for optimizations. And so in a lot of cases it is useful for especially geometrical engineering, but maybe not too much for a casual geometrical modeling like you do for game assets or anything on Houdini. But since I am using it a little bit for geometrical engineering, and I think by sharing it might be useful for somebody, I'm gonna show you how you can do this by using a physical simulations such as Vellum in this case. Now specifically I'm going to map the three-dimensional geometry onto a unit disk, which can be shown which can be found in several papers how you can do it, geometrically or physically, or with these papers. But what I'm going to show you is pretty easy to set up, since most of the hard mathematical part is going to be done by this Vellum. So this is how I'm gonna do today. First of all, you choose what kind of geometry you want to use to flatten and onto a 2D disk, such as this piggy head, Now, in order to flatten the geometry onto a 2D plane, you do need to have a seam or boundary. In this case, the pig head is a solid geometry, meaning there's no hole to this, so you do need to have a hole in order to create a flattened disc. So first thing I'm doing is to create some hole, something like these. The size doesn't really matter, you just need to have a one single hole here. Now there could be a multiple number of holes, but I haven't tested out yet, so maybe I can do it after I have completed the single hole procedural steps. Okay, so after you have found the hole, created the hole, the next thing you do is set up a boundary conditions by creating a disk shape, unit disk shape. Right now it's a bit dark, but there is a disk geometry on the center, something like this. So the number of points for this disk corresponds to the number of points on the boundary of this geometry, which is around here. Okay, so what I'm gonna do is to fix or move these boundary points onto a unit disk points, edges, then use it as a target or a pin target, which is not going to move during the Vellum simulations, and all the rest of the points or edges is going to be moving freely on 3D space. Now there are one single constraints that I'm going to attach to those edges to this geometry, which is a spring geometry, spring or string constraints onto every single edges with a rest length scale equal to 0, meaning it's trying to pull it's trying to become a single point. Each edge will try to become a single point by moving the endpoint and starting point, and the starting point to the same direction. I mean to the center direction, center points directions. But the edge, the corner, the boundary edge is being fixed. So as a result, what you get is this kind of pattern, and I'll show you how it looks like by setting up those conditions. And if you play it, this is what you get: simulations which fixes the boundary positions to a unit disk, but all the rest of the edges are all the rest of the edge have a constraints for strings constraints with a rest length equal to 0, meaning each of the edges trying to become edge length trying to become 0, but it's being pulled by these boundaries. As a result, you get this kind of a flat disk shape, which is a flattened pattern of a three-dimensional geometry, and which is also called as a conformal map. And looking at the angles locally, it is kind of preserving the angle. Not exactly the same angle, but as much as possible. Okay, as a result, you get this kind of a conformal mapping, and I'm going to show you one useful way to use this for maybe some modeling in Houdini, such as using it as a 2D UV map like this, then map it back to a geometry like this. So you can in this by using this method, you can have you can have a UV map for any kind of complex geometry, one single continuous UV mapping to a complex geometry like that, like this. And if you have a tons of holes, then you might need to tweak a little bit, but let's see if you can do that later. Then after you have this UV map on a three-dimensional geometry, you can use it for any kind of purposes after all, such as in my case, I'm trying to first of all place these letters onto a disk, then using some functions on the vex, I'm placing back to a geometry using UVs as a pattern, then render it somehow. So this is one way to use this conformal mapping, not really for optimization in this case, but just the geometrical modeling purposes, but still is useful in some case. Because most of the cases you want to do something like this without using this conformal mapping, what you need to do is, first of all, you have to create a UV layout on top of this geometry, which is a bit hard to do if it becomes really complex. Like there are nodes such as auto UV labs auto UV, which creates the automatic UV layouts on top of the geometry, and sometimes it works, but sometimes you have an overlaps on a UV, which makes it impossible to create a pattern like this. And you also have tons of seams in between the UVs because its purpose is to create the texture coordinate for a painting or texture mapping, of course, so it doesn't really need to be a single seamless geometry. But if you want the geometry like this one, then having a seamless UV map makes a lot of sense. So that's why there are some needs for this kind of mapping. Okay, so that's the introduction for this conformal map, and hope you find it interesting. Now let's see, I'm gonna show you how you can do this from scratch. Okay, and let me know if you have any questions for this. I mean, the implementation itself is not that hard. There are some things that I want to try after showing all the process that I have already created. So if you can stick with me, that'll be great. And if you can give me some feedback, that'll be also great. Alright, so let's have some geometry to test out. Something like this pig head. I'm gonna start with this pig head geometry. Okay, now there are several groups and attributes applied to this pig head which I might not need. So let's see, vertices UV. So it has a original UV value which is used to display these texture. So I'm gonna leave it for now. For the primitive, you have a material attributes and some of the groups. Now I don't think I need those group values, so I'm gonna delete it. Well, maybe I don't really need to do that. Now, first thing I would like to do is to create some holes to this pig head so that I can make it flatten out. It can be a small hole, like having a small hole somewhere around here, or somewhere here to the nose or somewhere. I'm just gonna create a hole using this clip node, and let's move this down a little bit. So let's say I have a hole or something like this. Okay, it should work with this kind of a hole as well. Okay, now I think it will make sense to have a triangular mesh for simulations. It might be easier for it the triangular mesh to do the simulations without self-overlapping. So I'm going to triangulate this by using triangulate. Okay, like that. Okay, now next thing I would like to do is to count the number of points on the boundary. Then create a triangular circle which have the same number of points with this number of boundary edges, boundary points. Okay, so in order to do that, first thing I'm going to do is to find out the border using a group points border and click include by edges, click unshared edges. We'll pick up the boundary points. Now I'm also going to use the divide node to this geometry and then check remove shared edges, which will remove all the interior points or interior edges and left out without the boundary points. Now this is itself have the same number of points as this boundary points here. So I'm just going to move those points to a circular positions by using small vex. Okay, now if I look at the numbering for this vertices or points, let's see, you can see that the numbering is jumping around like 0, 1, 2, 9, 8, 10. So I want to keep the numbering going from 0 to the end, incremented by 1. So I'm going to use the sort. Then point sort to vertex order so that the numbering becomes from 0 and incremented by 1 to the end. Okay, now that the point is in the order, I can use the point number as a angle for the circle inside of X. So I'm going to use the point angle, create the circle. And first of all, I have to create an angle which can be derived from the point number divided by the total point number. And let's make this float because you don't want to divide integer by integer. And multiply by pi multiplied by 2, which means 360 degrees. Then you can calculate the x and y value for a 2D circle using trigonometry. And without multiplying anything to this cosine and sine, you get a singular unit circle, meaning the radius is equal to 1. So now that I have this coordinate, I can replace the point positions with this x and y and keep the z to 0. Now you get this. Right? Can rectangular shape be used instead of disk? Yes, you can do that. You just need to change the boundary that I've just created to a rectangular shape. That's also possible. I mean, it can be any kind of shape. It can be like a shape for amoeba, could be a shape of stars or anything you want. If it's preferable shape is a convex shape, I think. Because if you have a concave, you might have some, like, how do I say, distorted triangles when you mapped from 3D to 2D. So square and rectangular shape is still a convex shape, so that I think it's fine. Right? So now that I have the circle, next thing I would like to do is to use this as a boundary condition for a simulations. Okay, now I am ready for the boundary conditions. Let's try to create some constraints for Vellum. Shall we? Okay, so first of all, I am going to use a Vellum constraints using distance along edges for a constraint type, which have only one single stretch force or constraints, which is only thing that I need, or maybe not the only thing. This is the one of the constraints that I need. And as a setup, what I need is, first of all, I don't want to have a self collisions in between this the points on this three-dimensional geometry, meaning I don't want to like have any obstacles during the simulations. I don't want to avoid moving those points because of the other points' radius. So I want to keep the radius of each point to 0, meaning set the thickness of the physical property to 0. You can do that by changing the thickness somewhere on here, set up uniform to 0. Okay, and also the important things that I need to set is to set the rest length scale to 0 for this string constraints, so that everything is trying to become a single point from a edge. Okay, meaning you have a really strong pulling spring. You have a really strong spring which starts from a length equal to 0. Okay, so whenever you try to make it longer, if you left your hand, then it will try to become the point again with a really strong force. So you can make this stiffness bigger to have a faster or stronger spring, but I'll just keep it as 1 for now. See what happens. So this is the constraint that I need, and another constraint that I need is a pin to the target positions, which means I want to pin those edge points, the boundary points, to this circle, so that it won't move from those points, the circle points. Now I can do that with some another constraints, or I can do that inside the Vellum solver dynamically. Now I'll do this dynamically inside a Vellum solver because I do also need to limit the point positions movement coordinate, since the disk is placed on XY plane right here. I also want to limit the final result of the point moving just only on top of this XY plane. So I want to limit the Z coordinate of the simulations to be equal to 0. So in order to do that, you need to go inside a subsolver to modify the point positions forcefully. So for that reasons, I'm also going to pin the boundary inside a subsolver. So let's give a subsolver, I mean not the subsolver but the Vellum solver, and let's connect all these. Wait a minute. Yes, and I'm going to read this circle information inside the Vellum solver by referring to a name. So let's name this boundary. Okay, let's go inside the subsolver and write out some dynamic properties for every frame. I'll do that using subsolver, accessing to a geometry node, because the only thing that I want to control is the point positions, so subsolver is enough. Okay, and go inside. I am going to attach a point wrangle to modify the point positions for each frame. First thing I would like to do is to pin the point of the boundary to the circle positions. So pin border. Now there, for this border points, I have attached a group called border, so I'm going to use this one. Then I'm also going to bring up the circle geometry using object merge, which was called as boundary, and which was outside subsolver. This one. Okay. So I got this circle geometry, and let's have this connected to the second input of this wrangle. Now, only thing I need to do is to first of all get the point position corresponding to the same point number. Wait a minute. Actually, in order to get the same positions, the corresponding point position, I do need to apply some ID to this boundary positions, I think, and also have it in here as well. So before applying the border group, I'm going to attach another point wrangle, given an ID to each of the point coming from the point number, so that after deleting all the inner edges with this one, you still preserve the ID as a point number. Looking at the geometry spreadsheet at the point, you get these ID. Okay, so this can be used to find out the corresponding points. Okay, going back inside the subsolver and the Vellum solver, subsolver. Let's find out the corresponding point using find attribute val. From the second input, the class is point, and the attribute that I want to look for is ID, and looking for same ID from the second input. So this should give you the result from the second input. The corresponding point number corresponds to this boundary point positions. Now you can get the position for the circle, then place the current boundary positions to a circle positions like this. Okay, so looks correct. Okay, some cap has been made. Alright, so I think it's good. And since this is going to be run on every frame, the point will never move. Okay, another constraints that I want to create for each of the points is to keep the z value for each of the point to be 0. So create another point wrangle, and this should work for every points. I'm going to unfilter this. I'll just say point zero, point z is equal to 0, and that's it. Being flattened out to xy plane like this. Okay, so this is enough. I think this should do the job, and let's go back to the geometry node. And another things that I need, another constraints that I need to set, or setups that I need to do, is by clicking the Vellum solver, there are options called self collisions. So I do need to turn this off as well, because I don't want to have a self collision in this kind of simulations. And I think that's pretty much it. I don't really need the gravity as well, so let's set it to 0. Okay, and if I play it, okay, something weird happened. Seems like every point has gone to a center positions. Okay, that's a bit weird. Let's see why. Okay, I am going to just keep this pin border and keep the rest of the stuff as it is and see what happened. Okay, if I play this, okay, still have some problem here. I might need to add another constraints to this one, which I have been doing on the the example that I made previously, but let's see if I really need to do that. Let me check the distance. If I set this to 1, let's see what happens. Interesting. Oops. Okay, let me check. So the distance, having distance as it is should be fine. Yeah, I think it should be fine. Set the uniform equal to 0 for thickness is fine. Ah, wait a minute. And setting the rest length equal to 0 should be also fine. Yep. So for this constraints, I think it's okay. Now going back to the solver, what I had is a pin, the bordering with a pin, which should also be okay. So let me add another constraints, which is called Vellum constraints, and I'm going to create additional constraints called pin to target, and set this to points and only for the border. Permanent, same as positions. Yeah, and that's pretty much it, and see what happens. Okay, now it's working. I guess I was missing some of the attributes for the points. After having this pin to target constraints, you get additional attribute to a point. If you look at the geometry spreadsheet, something like mass, p-scale, and so on. So I think these are the things that I was missing in order to calculate what I needed or simulate what I needed. Okay, but I can keep all the parameters set to default for this one, because I'm dynamically changing the properties inside the solver. So it looks good, I think. And let's go back to solver, enable z equal to 0 as well. And as a result, you see that I am getting this flatten out pattern from a 3D-dimensional geometry, something like that. And it should work for any kind of geometry if you have a single hole. So if I change the clip positions to somewhere around here, it should still work the same. Let's see, let's check. If I play it, something like that. Texture looks funny, but something like this. So everything looks good. I'm going to make this back to a little bit lower, somewhere around here. I'm gonna show you after you have done the simulations, the rest is really up to you how you want to use it. Most of the cases in three-dimensional modeling, you can use this for UVs. I think it's one way to use it. So let's try to create a UV map out of this circle, which is pretty simple. You just need to have something like UV project. And set this to orthographic probably, and let's also show up the new UV as a pattern, so you have a clean UV on a flat plane, flat unit disk. And then what you want to do is to remap this UV value to a original geometry, which is this one, so that you can use this new UV map for a original geometry. Okay, so in order to do that, I am going to use another point wrangle to remap the informations. Okay, so it's not that hard. I am going to modify the point position of this disk, which corresponds to the original geometry. You just need to move the point positions to the original point positions, and that's all you need to do to remap the UV. Something like that. Right? Easy as that. And then you get the original geometry, which have the new UV map, which is a single continuous UV map. And you can see that it's bouncing because of the simulations. Started from here. If you play it, you are seeing this optimization of this UV. If you want to finish this simulation as soon as possible, especially with this kind of a bouncing effect, one thing you could do is to go back to the distance constraints and change the damping ratio, something a little bit bigger. Will make it a faster result in this case, like this. Or you could increase the sub-step for this Vellum solver, which might be heavy for a high-res geometry, so I wouldn't do that. Okay, so looks good. Now that I have this UV map, what I can do is limitless. One way is to place, like using something like UV layout to place a geometry and continuous geometry pattern on top of this original pig head. So UV layout. First I'm going to lay out something like a text object on top of this disk, then remap it back to a original geometry. That's what I would like to try out. So let's create some text object. I could use any kind of font. Let's say Times, and I'm going to create a bunch of letters, something like these. And I want to have a random number of characters placed on top of this disk and packed inside a disk. Okay, so in order to do that, I need to make each of the geometry separated as one thing, one object. So let's see how I do it, how I do this. I guess there are several ways to do this, but since everything is each of the geometry is being connected as one piece, I'm going to use for each connected piece to access each of the characters. And first of all, move this into the center, meaning to 0, 0, 0 coordinate using transform node. To the center. Like that. And let's also apply an ID to this primitive, which can be used for a copy 2 points. So for a point wrangle with a meta node created, I'm going to create an ID, or let's call this TID, derived from the iteration. Okay. As a result, you have all the characters placed on the center, and each of the characters has this ID, corresponding ID. Right, from 0 to 6. In total, you have 7 values. Okay. Now, I probably need to know what's the maximum of this ID, so I'm gonna create attribute promote and promote the point TID to a detail as maximum. Change this to maximum TID so that you know how many characters are there. Now I can create a scatter point to the disk, scatter a number of points to the disk. Let's limit this to 200 for now, and have some variant attribute which can be used with the copy to point SOP. So copy to SOP points have an option to use this piece attributes, which is called variant, but I'm gonna replace this with TID. And by having this TID attribute to each of the point randomly set, you can place a picked up geometry which shares the same TID. So let's create this random TID value. And in order to do that, you need to know how many numbers, or what's the maximum number of TID. So let's get that from this attribute promote. max TID is equal to detail max TID, and what you want to get is the random ID using random, probably just using the point positions multiplied by some random value, and remap it to a value between 0 and max TID plus 1 and get the floor. As a result, you get a value in between 0 to 6 as an integer. Then have TID placed as an attribute. As a result, you don't get anything. Why it's that? Okay, am I missing something here? So these are the points. Okay, I think I need to also set the p scale to set the size. So let's say 1. Okay, and there is a problem with the orientation. That is because the normal direction coming from this disk is not straight but being angled. Probably not really. I think I need to recreate the normal directions right before creating the scatter node. Set this to point. This should give you a straight text. Okay, this looks a bit too big. Let's control the p scale manually, which doesn't really matter, I think, but let's see. Okay. Now, when you are going to map this onto a 3D geometry, this thing doesn't have an interior point, so which it's going to be a bit problematic because it's not going to be placed on 2D, but on 3D you do need to have interior points for a smooth surface. So let's change that by remeshing somewhere before going into the for loop. And the resolution is up to you, I guess. 0.05, which you still have tons of points on the boundary edges, which I don't really like. Let's set this point 0.3. Okay, well, these points are really unnecessary, so in order to trim that out, you can't do that with this remesh for the boundary. One way I could do is to create the group for the boundary points, just like I did previously. Then use this fuse only for those boundary points. Set this for points. Use the border and set the snap distance to bigger value, maybe corresponding to this target edge or target size. Multiply by 0.5 or something. Yeah, should do. Now the border becomes a bit cleaner. I think I like it. Maybe a bit too high res. Somewhere around here is fine, I think. Okay. Now that I have a bunch of characters, let's pack it to a disk using this UV layout. And we can do that by changing this to point position or UV attribute to XY projections, fine. Let's see what happens. I do need to use the second input as a target surface, so I think I need to change somewhere projection to, nope, this one. Where was it? Connectivity, target assignment, packing, targets, island from second input. Okay, there you go. And let's also change an angle. Have a various angle. I see that same characters being packed on similar positions, which I don't really like. How is that? Even though I'm being randomly sorting out, it still creates kind of a similar layout. I don't know if I can change that. Maybe, probably I could do this by setting some p-scale to random value because so additional random value, random multiplied by p with different random constants multiplied by p-scale. We'll create a better, bit interesting layout. Maybe I could fit this in between .5 to 1.0. Yeah, a little bit better. Okay, let's say I like this, and now what I want to do is to use this to DUV map together with this. How is the position is different? Huh. The position seems a bit off. Not sure why. Let's see why. After having this UV layout, the position have been offsetted somehow. Not sure why. Let's see if I'm doing something wrong. Anyone know why is that? Theoretically, it's possible to store spring distortion. I have a question from Kasali. Theoretically, is it possible to store spring distortion on points and influence somehow UVs on flat disk in order to have regular UVs on geometry? Interesting. Probably. Yeah, I think so. By accessing to attributes, tracking down those attributes, calculating the distortion, how much it changed from the original to the 2D map, you probably be able to calculate the distortions, but doesn't always means that it can fix the distortion on the final UV. You might going to have additional like distortions because of the three-dimensional angle. So, but it might be interesting things to experiment, I think. Okay, so what I want to do is to fix this position. Okay, I need to set this to P. Yeah, okay, now it's being fixed. Alright, so what I want to do is to use this UV map and this geometry, which is on top of the UV map, as well as the original geometry with the UV map. I want to remap this text object onto this geometry, which is not that hard to do because you have everything you need. So this is the text you want to move. This is the 2D UV map, and this is the 3D geometry with the UV map. And remapping. Okay, so first thing you need is the corresponding UV value for each of the point of this text sampled from this 2D disk, which you can get that by accessing to using the function called UV sample. Second input, the result you want to get is the UV, and the sampling value you want to use is the point position, and as a result you get the UV value. Now next thing you want to do is to get the point position on top of this three-dimensional geometry using corresponding UV. So similar to what you did here, final point position you want to get is accessing to the third input. What you want to get is the point position that what you want to use as a sampling is UV, and you want to use the one that you have just got as a sampling value. And as a result, you should be able to get the point position corresponding to the three-dimensional geometry. Replace this with the pos will give you a point position for the text, which is on top of the three-dimensional geometry like this. Easy as that. And rest is really up to you. You can, let's say, fully extrude to extrude this, have a thickness, merge it with the original geometry, and drawn out with some shaders. Probably I can recreate the normal direction as well. Just like that. Yeah, that's pretty much it. I mean, the way to use this map is, it's really up to you. Is one way you could use, which could be interesting in some way, but really not really limitless. It's up to your imagination or your needs. Now, there are things that I would like to try out, as I said previously. Right now, I am only accepting one single hole for the geometry to have this map. But what if I have several holes to the geometry? In those cases, the topology is more like a donut shape rather than a single disk. So in those cases, you need to tweak a little bit in order to be able to use the same flattening process. That's what I want to try out, but I might going to mess this up a little bit, so what I'm going to do is to create another verse, maybe creating a switch node, or just adding a clip node on top of this original clip node. And see if I can create another hole to this. I'm going to change the direction to something like this. Let's say I have additional 2 holes like this. Okay. So meaning right now I have in total 3 holes. And let's see if I can fix the process to work on this kind of situations. Okay. I'm gonna save this. I'm gonna keep this backed up just in case. Okay, so let's see. This was getting the border point position, I guess. Or was it? No. This is to triangulate, and this is to get the ID. This is to get the border point, and this is get the boundary. Now this has a little bit of problem because I am assuming there's only 1 hole, so I'm just creating a single circle, but instead we have 3 holes. So meaning you have 3 different border geometry out of this divide node. Okay, so that's one thing I need to be careful, and that's one thing I need to do something about it. So I think it's all about how you place those 3 islands corresponding to each other. In our case, maybe one of the circle might be a big 1 whole unit disk, and another all of the rest of the circle might go inside this unit disk, or this might be a bigger one and to have all the others inside the disk and so on. So you do need to have a little bit of rule here how you want to place those disks. One straightforward way to think it is to assume that the longer perimeter is the one you want to have as a boundary edge, and the smaller perimeter boundary will going to be placed inside this unit disk. And the position of the this inner circle might also be important, but let's see if we could create this kind of a rule here. First of all, pick up the longer perimeter, then place those other circles inside the longer one. To do that, you do need to calculate the perimeter for each edges. So first thing I would like to do is to convert this into a curve using polypath, and let's also make sure the number of points didn't change, because if it's changing, that'll be a problem. So it's not changing, so it looks good. Okay, now I'm going to use the measure node. Now these steps are not tried out previously. I'm just doing it on live, by looking at anything, so it might not work at all. Calculate the perimeter. Let's look at the primitive. Yeah, get the perimeter. Now you see that some of the first perimeter is the longest, all the rest is smaller. So let's sort it out. Sort the primitive based on the perimeter first of all by attribute. perimeter, reverse primitive sort, attribute, wait a minute, like that. And how do I do this? Now rest is really up to you how you want to place it. Place a circle. Probably, I mean, you still want to have the sort to sort the vertex order out, so I'll keep it as it is. So connect this like this, and what you want to do is access each of the primitive separately. So instead of using point wrangle, I'm going to use the primitive wrangle instead. And create circles, trying to create the circles for each of them. Now you know that the first primitive is the largest, so that will be the one that you want to set the radius is equal to 1. So I'm going to copy all these to this one. Now for the primitive, you need to access all the points correspond to belongs to this current primitive, so using point prim points. And if you want to change the point position, you need to loop through all the points. Just like that. Okay, now you get the point position. I don't think I need this after all. Now you get the point angle, which in this case the PT num can be replaced with the I, and the endpoints can be replaced with the number of points here. So like this. And all the rest is okay. For this one, you need to first of all create a variable for the position to store the position. Then call set point attriv to replace the current point positions at PTSI with the new positions. Now this will make every circle being placed, every border placed as circle. I think these are the cache. Okay, I think I'm seeing some unnecessary cache. Or do I have 3, yeah, I think I don't know how to remove those caches. Every time I see it, cannot seem to get rid of it. Even if I change the view. Damn. Well, one way you could get rid of it is to add a new view, which will remove. But I don't really like this way. Okay, well, anyway. Now, currently, every circle has same radius, so it's being placed on the same positions. Now, I want to fix that by changing the radius for the smaller perimeters. Now, I guess the radius could be relative to the perimeter. So let's say in order to change it as a radius, how do I need to do? Maybe I can just say multiply the point position by the current perimeter. Okay, well, that might do the job. Now, next thing you want to do is to change the circle position so that it doesn't overlap. Currently the two small circles been overlapping to each other, which you don't really want. So that's a bit tricky. Yeah. How do I tackle this problem? Well, I'm going to create a... Anyway, you might still need a manual tweak after all, but I'm gonna try to make a procedure as much as possible. First of all, you could split the geometry into the most biggest one and the other one, like this. So this is the biggest one, or the largest one, and this is the rest of it, the rest of the circle. And you could create a closed geometry out of this largest circle using primitive, then scatter a number of points, and the number can correspond to a number of rest primitive here. So n prims rest will give you 2 points. Well, I don't really want to have it on the edge, so okay, I might want to transform, scale this circle a little bit smaller, like 0.8 or 0.7, 0.6, 0.5, I don't know. Then place these rest of the geometry on top of this points. Since I want to separately place this to each of the points, I can use another copy 2 points using a variant, and for each of the point and primitive I can set the variant. This can be a point number, and this could be for each primitive I can just do it right here. So set point attrib 0 variant pts I prim num. Now the small circle starts from 1 because the biggest one always have 0 as a variant value. So let's go back to this one and say +1. Okay, this will do the job. Now it is still overlapping, so let's tweak that out by having manual control to the p scale, which might not be smart, but I just want to test it out if this is going to work. If you know that this is going to work, then there might be a bit more smarter way to automatically give best circle positions. But there are no like one best positions for the circle. Maybe changing the circle positions to anywhere you want might be a good experiment to test out the result. I mean, it's really up to the purpose. Okay, it's not changing. That is because you need to do this to a point. Okay. Now looks good, and let's merge all these. So the biggest one comes to the first input, rest. So something like this. So you have a single big holes on the boundary, and you have another small two circles on inside, not overlapping to each other. Alright, so that's what I wanted, and that's what I want as a new boundary information. Alright. Hopefully this is going to work, and all the rest, I'm not sure if I can keep it as it is. Let's see. If I play it, no, it's not. So what I presume what to happen is that you're going to have a hole to this disk, but I don't really see that happening. So there might be something wrong with this setup somewhere. So let's see where. First of all, let's look at the boundary, and let's check the point attribute, which is called ID. Let's show up the ID at Okay, I'm not seeing anything here. Am I missing some toggle? Not sure. Okay. Let's also make the guide text a bit bigger. It's hard to see here. Okay, so these are the ID, the reference ID for the circle. Okay, there are some weird thing happening here. Might need to fix that first. Let's see where that is. This is close to... Wait a minute. Wait a minute. Oh, it seems like some of the ID is being shared. That's totally wrong. Yeah, that's totally wrong. Where that happened? Where did that happen? So I have this ID here. Okay. Yep. Okay. Now, going here, create the border. Should still be fine, and okay, I guess the ID has been changed by using this polypath. No, not really. Nope, still not being changed. Perimeter. Wait a minute. Sort. Circle. Wait. Rest. How am I having these same ID values for this one? And also these. That's where it becomes wrong. That is probably because of this copy 2 points, I guess. Yep. Yep. That is because this piece, this point have this ID. So that's the reason I need to remove that attribute delete. Need to remove this ID value, which should preserve the original ID. Yeah. Okay, let's see how it's gonna change. Okay. Okay, something has happened, but not exactly what I wanted to see. Well, I wanted to really have a hole here, but no, it's not really what happened. Okay, so I guess you do need to have the best positions for the circle in order to have that kind of effect. Because it's right now it's being self-intersecting. It's not really the best point positions. So I guess you cannot really fix the circle positions, but instead you do need to make it possible to move around the disk, same as these edges. That's what you need, I guess. So the only boundary conditions you want is this largest one and not the smaller ones, right? So that means you can remove the border for the smaller ones, which you can do it in where you can do that. Maybe I can, after I got the largest circle, I can go back to the border group using a point wrangle, accessing to the largest one, and only keep the border if it has the same if you could found out the same ID out of this largest. If not, then remove the group. So int pt is equal to find attrib val point ID and if pt is negative, then you couldn't find the point. Then in those cases, set the border group to 0, like this. Now let's see what happens. Well, why do I have this 3D pig head? So as a result, yeah, I think this is what I really wanted. So I do see these circles being created, but not being constrained. So you still have a hole, but it automatically being placed with the simulation. It was much smaller than I assumed, but looks interesting. Now the interesting part of this one is that you can, I think you can switch the order. I mean, you can switch which border to use. Right now I have used the largest perimeter, but by changing the order, for example, where was I doing it? So change the order using this sort. This sort. Instead of using the perimeter, maybe right now it's being ordered from the largest perimeter to the smallest perimeter. If I change the order to the smallest, largest, then the smallest border, it's going to be chosen as a base boundary edge, and as a result you get a different kind of mapping, and you have two holes inside. One that used to be a bigger perimeter, one is the other side of the ear, and you get a different kind of UV mapping out of this. And if you use it for geometry mapping, you get totally different result. So it's been, the ear part is really dense, and all the rest is kind of a sparse. It's more like a character from Marvel. Alright. So this is an interesting testing. So seems like you didn't really need to set your inner circle position by yourself, but instead it just gives you the automatic allocation by picking up the largest. So what I tried out here is not really necessary. I can just remove it. And change the boundary to directly connected to the largest, and this should do the same job. Let's check if I play it. Yep. And if I change the order, the sort to largest to smallest, could still give you the. Okay, well, previously I got the questions if it can be done on rectangle, so let's see if I can also do that instead of circle. Okay. So the point position for the rectangle is not really straightforward compared to a circle, so you might need to create some conditions. Okay, so let's see I have number of points here, and instead of using trigonometry like this, you need to do something else. Well, let me think what's the best way to tackle this problem to make it rectangular shape. Let's see. Well, one of the way you could do is to constrain the value which you have gotten here to a static value. I mean, this x, y will be either positive or negative, right? So if it's positive, then keep it to a single constant value to the positive positions. If it's negative, then keep it to the negative constant value for both x and y. Let's see what happens. If x is equal more than 0, then set this to say 1, else x is equal to -1. If y, just copy these. If y is more than 0, and it does look like a rectangle already. I guess it's okay. It looks okay. Although, yeah, one problem is it doesn't have an in-between points, which is a bit of a problem, so do something here. Okay, so let's see what's I think the condition should be changed based on the angle, the current angle. So if it's, let's say, if this is the -45 degrees and this is the 45 degrees, so in between -45 to 45 degrees, you can set the x with this, but for the y value you need to go from -1 to +1 gradually. So those kind of constraints must be added, right? So so fortunately we do have an angle value here. So if an angle is more than 0 and angle is less than 90, pi multiplied by 0.5, or angle is in between pi multiplied by 0.5, I mean pi, and angle is less than pi multiplied by 1.5. Use these conditions, else use these conditions. And I think I have some syntax error here. And do seem to have some value, but yeah, I have this corner problem. That is because I need to say from -45 degrees to 45 degrees, but right now I'm saying from 0 to 90 degrees. It's a bit of a problem. So I'm going to create the testing angle, which is the current angle minus pi multiplied by 0.25, which is 45 degrees, and replace it with this angle here. T angle, T angle, T angle, T angle. Is it wrong? Is it right? No. Let's see. Nope. If I edit. Okay, close. Now I have a problem on the corner. So some point might not meet the conditions on the corner, which is understandable. So we can divide the I into 4. So if we meet those index value, I'm going to force the point positions always met with this condition. Wow, that's a lot to do. Okay, so if I is equal to What's the best way to tackle this? I divide by the length of PTS divided by 4. And no, not the floor, but wait a minute. Modulus. And if it's less than 1 or less or more than 1, then that's why you want to made it fix or corner. Okay, this seems like a really stupid way to solve. If it's that complex, I should have done it more easy way. Well. Okay, where is the problem? Huh. Oh well, it's not really working after all. Let's forget about it. Forget about it and let's make it a bit simple. Let's see what's the best way to tackle this. I can just create a rectangle shape for each of the circle. Somewhere I can just create a grid, but still needs to know how many points. Okay, might not be a good idea after all. I'm sure I can use this value some way, or just use I for some purpose. So let's say int n is equal to I modulus the length of PTS divided by 4. Okay. and well, for those points, and you could also have a calculation between I divided by 4. Right. Okay. Well, okay, well this time is really not necessary. Let me just test out if this shape, I mean right now this is really not a rectangular shape, but what I want to prove if this is going to work for a convex shape. So this is still a convex shape, so we can just test this out first of all. See if it's going to work. If it works, then I can focus on how I can create the grid. Okay. Play it. And as you can see, it still could work for a convex shape. So theoretically could work for a rectangle shape. So it will be and recreating the UV is also possible. Might make more sense to use it as a UV map. I don't know. Well, so it does work. Only thing I'm missing is this correct way to make it as a rectangle. I think I'm making too complex here. I can see that. I can see that. Right. Well. Float value is equal to n divided by this thing here. Really don't like it. Oh well. Let me look at the circle position. And what I was trying to do is to project these point to x, y. And at the same time, I do need to scale the y direction for this x corners and x scale for y edges, y borders. I see. Okay. Instead of doing like this, what I'm gonna do is to try to recalculate the scale value so that the overall shape look like a rectangle. That make more sense. Okay, so right now the radius is calculated by a multiplication, the power of 2 for this x and y, then calculate the root 2. But instead of doing that, what I could do, I could multiply it by plus y. Nope, not really. Wait. Let me. I need to have some sketch here. So. So what I want is this rectangular shape. So in order to do that, you need to recalculate this radius. Okay. And let's think how we could do this. Now, if we have the angle like this, and the x is always equal to 1 in this case. Now if we have an angle like this, then the y is always equal to 1. Right, makes sense? So in this case, r multiplied by cosine theta z is equal to 1. So r is 1 divided by cosine theta, right? So for this conditions here, after 45 degrees, the condition changes, I think, from this to this. So at this point position, we have an angle, another angle. In this case, r multiplied by sine is equal to 1, so r is 1 divided by sine r. Right? Right. And for these, this is still positive. I mean, that's negative, yeah. It's negative, but in this case, r1 multiplied by sine alpha is -1, but this is also -1, so based on the angle conditions, you can do either this or this for the radius. So if it's in between minus 45 degrees to 45 degrees, or 135 degrees to wait a minute. This angle is 135. No. So, and we should look at this angle here, which is what? 225 degrees to 315 degrees. We'll be using this cosine, and rest of the angle use this equations, probably. Okay, well, let's move this aside, give this as a guide. Let's see if it's gonna work. So let's create the conditions. If degrees of an angle I think the value right now is in between 0 to 360 degrees. So let's have this minus pi, so that it will be in between minus 180 degrees to positive 180 degrees. I'm gonna use the C angle as a checking angle. So 180 degrees. So if Cang is more than 45 degrees and less than minus 45 degrees to positive 45 degrees, or angle is larger than so it's a negative value, so what's that? Okay, wait a minute. Okay, I think I did wrong. This is not correct. This is not correct, but it should be in between 135 to 180 and minus 180 to minus 135. Well, that's really not a clear value to check. Wow. Okay. Instead of using degrees, I'm just gonna use a radians after all. So first of all, I'm going to shift the angle by 45 degrees. Then it will be much easier to check if C angle is more than 0 and C angle is less than pi, or pi multiplied by 2 multiplied by 0.5, which is 90 degrees, or C angle is larger than pi and less than pi multiplied by 1.5. In those cases, set the radius to 1 divided by cosine angle, so 1 divided by cosine angle, else radius is equal to, and multiply the radius here. Oops. Okay. Still something wrong. Should be doing something wrong here. So what is wrong? What about this? R is 1 divided by cosine theta, but it is a negative value. Cosine theta in this case is negative. Right. Well. Okay, well, let me see. Didn't really work. That is because I didn't concerned about the negativity. Looks pretty simple problem. Right. And wait a minute. Should it be signed? Okay, well, it didn't really thought about the negativity here, so we should say this is the absolute. Close enough, close enough. This is close to what I want to have as a rectangle. The problem is some of if you want to have a straight corner, you do need to have an angle equal to 45 degrees at some point if you want to do it in this way. And right now, obviously, I don't have an exact 45 degrees angles created here, so that's what I need to fix. Well, I can constrain the one that's close to 45 degrees, but there is a chance that some of the points be merged, so it's pretty hard. Well, I guess I can fit the point position to rectangle right after I calculated this right here by creating the boundary and fit, but I'll still have some problem here. It will be best if I could do it all in one here. So one that I can think of is to find an angle which is close. Okay, first of all, what I can do is to calculate the step angle. In between points, which you can do that by you can do it outside a loop by 1 divided by this value here. This will be the step angle, and this could also be used as a threshold in order to determine where is the corner. Okay, now what I can do is float the remain angle is equal to current angle calculate the remains with step angle, no, not the step angle, but pi multiplied by 0.25, which is 45 degrees. Okay. And if the angle is less than step angle, then change the angle value to floor ang divide by pi multiplied by 0.25 multiplied by pi multiplied by 0.25 and there you go. It's kind of a brute force way to fix, and I'm not sure if the threshold is correct. Maybe I should multiply by 0.5. Maybe not. Well, seems to work. Not sure. There might be some duplicated points on the corner. I hope not. Right now it is not. Well, close. But seems you do have a straight corner without any duplication, so seems good. You do have a little bit of space in between because you have forcibly fixed the positions. So it's not an optimal way to solve, but can be considered as one way. Alright. Well, by using this method, I think you could forget about it. I think I wanted to say that it might be able to work on polygonal shape, but no, didn't. It does not actually, so in this case, because I have these conditions for rectangle. If you want to do it, then there should be a much better way to precisely do it. So if I switch this to rectangle shape, set it as boundary, should be able to create a square mapping, which I don't really think this kind of conformal mapping is being used for optimization purposes, but for geometrical modeling purpose it might make sense to have a square, because you have more UV value which can use the whole space, which might be interesting, which might be useful. So maybe can consider it as an interesting way to create a UV map without any loss and using a single plane. Right, well, but as you can see, there are distortions, so you do see a geometrical distortions on a remapped geometry as well. So maybe not really optimal for most of the cases, but might be interesting in some way. It's really up to you how you want to use it for, why you want to use it for. So that's pretty much it that I wanted to show. Let me know if you have any comments or if you have any feedback, what you can do with it, what's the other approach you could think of or anything. If not, I'll just end here. I myself is pretty satisfied trying out these geometry with the hole. Seem to work with easy setup. It could give a lot of possibilities for geometrical optimizations. I could have many holes as much as possible. Let me test out. with these several different holes. Open up. How's this? So in total I have 4 holes, and if I set this to circular map, yeah, I still get the result. Interesting. And should work for any kind of geometry, I hope. Rubber toy has a different island, so it might not work out of the box, but let's see. So these legs are different island as a geometry, so these might be a bit of a problem because it's not really constrained to any borders. So which might give you a different result. And my presumption is that these geometry is just going to fly away to somewhere else because it's not being constrained. Let's see it. So I guess the one that's been the leg part has gone somewhere, I think. It's not really shown here, but it should be scaled down to 0 positions and fly away somewhere or went to the center. But if it's connected, it can still work, so I can say that this could work for any kind of geometry. Right, so that's pretty much it. I'm not sure if you have any questions. If not, I'll just gonna end this and save the file somewhere. Okay. It's interesting. We have a bigger hole here. Okay, so this was to create a conformal mapping using Vellum procedurally, and the setup is not that hard to create, and the purpose of it can be anything. One way I have shown here is to use it as a UV map, but on geometrical engineering field you could use it as a base, a plane to do optimizations, then bring it back to the original 3D space. So if you are more into geometrical operations, geometrical analysis, those behind the scenes stuff, then this could be useful in some way. Okay, that's it. Thank you very much for watching. I am going to upload the file to the GitHub as always, which you can download from the video description page. And down. I'm also going to record this, keep this live stream as a archive recording, so you can watch it anytime. I'm also going to upload the files to their Patreon page, so if you could support, that would also be great. You can also go from my description page of this YouTube video. Okay, that's it. Thank you very much for watching. Hopefully you find it interesting. I myself really found it as amusing to use Vellum for conformal mapping to create a UV map. Hope you felt the same, but I don't know how you felt. Okay, well, let me just organize this and I'll finish this live. If you guys are still here, let me know if it was, I don't know, too easy, too hard, not that interesting. If you want to see something else or anything. Okay. These are test clipping. Right now, ID, water. Okay. Well, there aren't much parameters set for these setup. It's pretty simple setup. Maybe for these text remapping might be some where I could control like number of points. I'm not using this P scale after all. And that is, I guess, pretty much it. Thickness, well, not really important, but okay. Oops, that's too much. I should limit the number to 1000. Alright, okay, so thank you for watching and good night. Thanks for all the, if you're still there, thanks for watching. send this.